right now, you are falling through space. Not metaphorically, not poetically, but truly drifting inside an immense hollow of the universe. A cosmic cavity so large it could swallow billions of galaxies whole. It stretches for roughly 2 billion light-years from edge to edge, a silent abyss in which our own Milky Way floats like a speck of dust suspended in sunlight. No one ever told you this, because most people still have no idea. In 2013, 3 astronomers, Ryan Keenan, Amy Barger, and Len Cowie, were counting galaxies across the sky when they stumbled on something that should not exist. Wherever they looked, there were fewer galaxies than expected, not just a few missing, but 1 in every 5 simply gone. When they mapped the empty space, they saw a vast bubble of near-nothingness, with our galaxy sitting eerily close to its center. They called it the KBC Void, named after their initials, though nothing about it feels casual. It is the largest known void in the cosmos, a region where the very fabric of existence seems thinner, lighter, quieter. This discovery rippled through cosmology like a fault line. For decades, scientists assumed the universe looked roughly the same no matter where you stood. That assumption kept our equations tidy, our models elegant. But inside this hollow, the rules bend ever so slightly. Light moves differently here, gravity tugs with a softer hand, and the expansion of space itself seems to run faster than it should. From our telescopes on Earth, we measure stars racing away, supernovae flashing in the distance, and we think we're seeing the true rhythm of the universe. Yet perhaps we're only watching a local illusion, shaped by the emptiness around us. It is a humbling thought. Everything we know about the cosmos, its age, its size, its destiny, may depend on where we happen to be standing, or rather, where we happen to be floating in this invisible desert. Maybe the universe is not lying to us, only whispering from behind a curved mirror. So the question becomes, what if the universe we see is not the universe that is? What if all our maps, our measurements, our cosmic clocks are slightly warped because we're observing from inside a giant hole in reality? The deeper we look into this void, the more it seems to look back, asking us to reconsider everything we thought we knew about where we are and what it means to exist in the emptiest place imaginable. To understand the hole we live in, we first have to see the fabric that holds it. The universe, from a great enough distance, is not a smooth sea of stars, but something far stranger, a tangled web woven from threads of matter and light, stretched thin across unimaginable scales. Astronomers call it the cosmic web, a pattern so vast that no photograph can truly capture it. From far away, it resembles a sponge or a foam, with glowing filaments of galaxies surrounding immense pockets of emptiness. Nearly all the mass, every planet, star, and cluster ever born gathers along those filaments, leaving the spaces between them astonishingly bare. Roughly 90% of the cosmos is empty space, not the kind of emptiness you find between stars, but a void so profound that entire galaxies could drift through it for billions of years without ever meeting another. Only the remaining 10% holds the visible architecture of creation, those luminous threads that connect the universe like the veins of a living creature. Within those filaments, galaxies cluster together in walls and knots, feeding on gas and dust, forming stars, growing heavier over time. Between them lie the dark regions, the cosmic hollows that stretch for hundreds of millions of light years. It is inside one of these hollows that we quietly float. This pattern was not always visible. For most of human history, the night sky appeared scattered and random. Stars dotted the darkness in no obvious order, a flat mosaic painted on the inside of a cosmic dome. Only when technology allowed us to measure distance, to know which galaxies are near and which are far, did the illusion dissolve. What once looked like chaos began to reveal its shape. The galaxies, when plotted in 3 dimensions, aligned themselves into threads and walls, curving across space like frozen waves on an ocean of time. The more astronomers mapped, the more the universe resembled an intricate lace of light. At the heart of this structure lies an ancient story, one that began before stars, before atoms, before even the first light. In the earliest fraction of a second after the Big Bang, the young universe was a dense, hot soup of energy. Tiny quantum ripples danced through it. Random fluctuations in density, smaller than the width of an atom. Most of those ripples faded, but some were ever so slightly denser than others, and that small difference changed everything. Over billions of years, gravity amplified those subtle variations. Where there was a little more matter, gravity pulled in more, thickening the cosmic broth. Where there was less, gravity had less to work with, and those regions slowly drained of material. This quiet imbalance sculpted the skeleton of the cosmos. Dense regions collapsed into galaxies and clusters, while underdense regions ballooned outward, expanding faster than their surroundings, leaving behind the enormous voids we see today. What began as whispers in the quantum fabric became the grand architecture of the universe itself. Looking at the cosmic web today is like gazing at the fossilized bones of creation. Each glowing filament marks where gravity won its battle against expansion, where matter clung together instead of drifting away. The voids between them are places where expansion triumphed, stretching space so much that almost nothing could form. These two forces, gravity pulling inward, expansion pushing outward, wove the universe into a delicate balance of presence and absence, fullness and silence. The scale is beyond comprehension. The largest known walls of galaxies can stretch for over 1 billion light years. Within those walls, clusters sparkle like cities seen from orbit, while the voids between them are vast deserts where even light seems lonely. From our tiny vantage point on a small planet orbiting a modest star, it is easy to forget that we are part of that pattern, that our own Milky Way is one thread among countless others. Seen this way, the KBC Void becomes less of an anomaly and more of a natural feature of the cosmic design. Voids are not mistakes. They are the spaces that allow the structure to exist. Without emptiness, there would be no contrast, no definition, no gravity wells to anchor the galaxies together. The cosmic web needs its hollows just as much as its filaments. We are, quite literally, creatures of the void. When scientists render the web in 3 dimensions, the result looks hauntingly familiar. A vast, sponge-like network glowing faintly at the edges, every bubble an ocean of darkness, every strand a bridge of galaxies. It is humbling to realize that nearly all of existence hides within those thin threads. What we think of as the universe is really the leftover scaffolding of matter clinging to the edges of cosmic emptiness. So when you look at the night sky and see its scattered stars, you are not gazing into a random sea. You are peering through the translucent skin of a much larger shape, a pattern older than time, one that stretches across the observable universe like the weave of a celestial fabric. Somewhere within that fabric lies our own hollow, a bubble of thinness where gravity relents and space runs free. The universe, for all its brilliance, is mostly made of nothing. And that nothingness is what gives it form. Perhaps the most astonishing truth of all is that the structure of everything, the galaxies, the stars, even us, was born from fluctuations too small to imagine, amplified across billions of years into a lattice of light and shadow. From quantum tremors came cosmic geometry. From silence, a song of creation. So the next time you picture the universe, try not to see it as a glittering expanse filled with stars, but as a kind of ancient cheese, full of holes where light lives only on the thin surfaces between vast stretches of emptiness. Somewhere inside one of those holes, suspended in the dark, our galaxy drifts quietly, unaware that it resides not at the center of the universe, but in one of its emptiest corners. Somewhere within the tangled web of the cosmos lies a region that seems almost too vast to belong to the same universe as us. It is not a cluster of galaxies or a wall of light, but rather a hollow, a place where matter thins to a whisper. Astronomers call it the KBC Void, a name that carries little of the awe it deserves. It is the great nothing that surrounds us, stretching roughly 2 billion light years across, enveloping our entire galactic neighborhood like a bubble so large we could never see its edges. Inside this quiet gulf floats the Laniakea supercluster, our cosmic homeland, home to the Milky Way and 100,000 other galaxies, each one an island of light adrift in the dark. To put that scale into something the mind can touch, imagine traveling at the speed of light, moving without rest, without pause. It would take 2 billion years just to cross from one side of our void to the other. 2 billion years, longer than the age of most galaxies. Yet, in all that distance, you would pass through almost nothing. The density of matter here is only about 15% of the cosmic average. It is not an empty space in the ordinary sense, but a gentle thinning of existence itself. Fewer galaxies, fewer clusters, less gas, less dust. Even the invisible dark matter seems to grow faint, as though gravity itself tires in this vast expanse. From a distant vantage point, if one could somehow see the cosmic web stretched before them, the KBC Void would appear like a transparent bubble embedded within the larger structure, its surface faintly outlined by filaments of galaxies curling around its rim. Inside, the stars are sparse. The few that exist drift apart slowly, following the quiet rhythm of expansion. They shine not in crowds, but alone, solitary lanterns glowing across unimaginable space. The Milky Way is one of these lanterns, not at the center of anything, not anchored to any wall or filament, but gently floating in the middle distance of this hollow, bound only by its own gravity and the faint pull of others far away. Such solitude is difficult to grasp. Most of the universe's drama happens along the filaments where galaxies collide and merge, where gas clouds ignite into stars, where black holes feast and galaxies grow old. Inside a void, everything slows. Encounters are rare. Time stretches in quiet tones. Galaxies here age without much interference, evolving at their own pace, almost untouched by the cosmic crowd beyond. They are like remote villages in an infinite countryside, seeing only a few travelers pass by across the ages. When the KBC Void was first proposed, it sparked both fascination and disbelief. Astronomers had long known of smaller voids, but this one was colossal, unlike anything seen before. Some doubted its existence, suggesting the data might be misleading, the result of how we observe light from faraway galaxies. But as more surveys mapped the sky in finer detail, the pattern became undeniable. The galaxies truly did thin out around us, not evenly, but in a gradual gradient, fading as distance increased. Our cosmic neighborhood was indeed special, not because it overflowed with stars, but because it lacked them. The irony is almost poetic. For centuries, humans assumed they were at the center of creation, only to learn they were not even close. Then, after generations of humility, it turns out we might occupy a peculiar position after all, a cosmic middle of nowhere. The KBC Void is not empty in a way that should make us feel insignificant. It is empty in a way that makes our existence improbable, like a single candle flickering in a cathedral of night. That thought carries a quiet weight, a mix of wonder and unease. Within this great hollow, the rules of measurement bend in subtle ways. Light traveling through the underdense region moves through slightly different gravitational conditions than light crossing denser areas. Over billions of years, this can distort how we perceive distance, brightness, and even time. When astronomers use nearby supernovae to calculate the rate at which the universe expands, they might be unknowingly measuring the speed of space inside this very void. It means the emptiness around us could be tricking us into thinking the entire universe expands faster than it truly does. Such a realization is both beautiful and troubling. It reminds us that observation is never separate from location. The universe does not hand out its secrets evenly. Perspective shapes truth. From inside the KBC Void, we might see the cosmos through a slightly warped lens, like fish staring outward from within a bubble, believing the entire ocean bends around them. Still, there is a strange serenity to this emptiness. The galaxies that share our void are few but luminous, each one a small miracle in an ocean of nothingness. They drift, they spin, they give birth to stars and planets, unaware that they inhabit one of the most desolate expanses in the known universe. The silence here is not the silence of death, but of balance, an equilibrium between expansion and gravity, between presence and absence. The KBC Void is, in a way, our cosmic cradle, Everything we see in the night sky, every atom in our bodies, every photon that touches our eyes moves within its invisible walls. We are creatures born in the thinnest air of existence, living in a place so empty that its very emptiness changes how we understand reality. The void is not beyond us, it is within us, surrounding us, shaping every number we write about the cosmos. Somewhere, near the faint edges of this bubble, the filaments begin again, thickening with galaxies and clusters, rejoining the web of cosmic light. Beyond that lies the rest of the universe, dense, lively, full of motion. But here, in our hollow, space expands a little faster, gravity whispers a little softer, and time drifts like dust in sunlight. This is where we live. This is the quiet heart of the cosmic web. Yet the very stillness that makes it peaceful also hides a subtle distortion, a flaw that bends the way we see everything beyond. Perhaps that is the truest mystery of all. The great void around us is not just an empty room in the universe's house. It is a lens, a trick of light and gravity that touches every measurement we make. Somewhere in its vast calm, the universe may be smiling, knowing that the answers we seek are already entangled with the hollow we call home. There's a quiet argument unfolding at the edge of the universe, an argument about speed, distance, and the nature of time itself. For more than a century, astronomers have tried to measure how fast the universe expands, tracing its motion back to the moment of the Big Bang. The number that describes this expansion is called the Hubble constant, named after Edwin Hubble, the man who first noticed that distant galaxies are racing away from us, their light stretched and reddened by the stretching of space itself. It sounds simple. Measure how far something is, see how fast it moves, then find the rate of expansion. But the universe has never liked simplicity. When scientists look deep into the early universe, they study the cosmic microwave background, the faint afterglow left behind about 380,000 years after the Big Bang. It is a frozen image of the cosmos as it once was, a baby picture of everything. From its delicate ripples, physicists can predict how fast the universe should be expanding today. That number is around 67 kilometers per second per megaparsec, a way of saying that for every million parsecs of distance, the universe expands by 67 kilometers each second. But when astronomers measure the expansion using the light of nearby stars and exploding supernovae, the story changes. These are not baby pictures, but recent snapshots measuring the rhythm of the modern cosmos. That number turns out to be around 73 kilometers per second per megaparsec. The difference between these two methods, roughly 9%, may not sound like much, yet it has shaken cosmology to its core. It is as if the universe tells one story about its past and another about its present, as though it is lying to us, or perhaps as though we are misunderstanding what it's trying to say. This discrepancy is known as the Hubble tension, a gentle name for a deep crack running through the foundation of modern physics. Both sides of the measurement are incredibly precise, supported by independent teams, powerful telescopes, and decades of calibration. Yet they refuse to meet. Either the early universe behaves differently than we think, or something about our local corner of space is altering what we see. Here is where the idea of the cosmic void, our invisible home, slips quietly into the discussion. Inside a region that is less dense than average, gravity has less matter to pull on, so expansion happens just a bit faster. Space stretches more freely, like a balloon expanding in a place where the air is thin. Light passing through such a region carries that local rhythm of expansion with it, making the universe appear to accelerate more than it truly does. From our perspective inside the KBC Void, we might be measuring not the universe's global heartbeat, but the quicker pulse of our hollow surroundings. Think of it like standing in a shallow pool that drains water faster than the rest of the lake. From your position, it seems as though the entire lake is lowering rapidly, but what you're really observing is the unique behavior of the small basin you happen to stand in. The universe may be doing something similar to us. Its great expanse remaining steady while our local bubble swells a bit faster than the rest. For cosmologists, this is both an elegant and unsettling idea. It would mean that some of our most trusted numbers, the age of the universe, the density of matter, even the strength of dark energy, might all need quiet revisions. It would also mean that we occupy a special, though accidental, position in the cosmic map, somewhere that just happens to be thinner, lighter, more hollow. The laws of physics would remain intact, yet their interpretation would shift, like realizing the ruler we use to measure the world is slightly bent. Still, the alternative is no less dramatic. If the void is not to blame, then perhaps something fundamental in physics is missing. A new particle, a new form of energy, a hidden twist in gravity itself. Some researchers have proposed that dark energy, the mysterious force accelerating cosmic expansion, might have grown stronger over time. Others suspect that the early universe contained exotic matter that has since vanished, changing the pace of expansion between then and now. The Hubble tension, small as it seems, is the loose thread that could unravel the entire fabric of cosmology. What makes this puzzle even more haunting is its subtlety. Nothing in our daily experience changes. The stars still rise, galaxies still turn, the night sky remains serenely indifferent. Yet beneath that calm surface, reality contains a quiet contradiction. Two truths, both beautifully reasoned, both meticulously measured, refuse to agree. The universe appears to be expanding at two different speeds, depending on how you ask the question. Inside the KBC Void, that contradiction feels almost poetic. We are surrounded by emptiness, and perhaps that very emptiness is bending the numbers, reshaping our perception of cosmic time. It is not that we have measured wrong, only that we have been measuring from within a hollow lens, unaware of its subtle distortion. Like a voice echoing inside a cave, the sound of the universe reaches us warped by the shape of the space it travels through. So when scientists debate whether the cosmos is expanding faster or slower, they may really be asking how much our position within the void changes what we see. Perhaps the universe is not deceiving us at all. It is only showing us that truth depends on perspective. From inside our cosmic bubble, the fabric of reality might simply appear to breathe a little quicker, stretch a little farther, pulse with a rhythm that is not universal but local. In that sense, the Hubble tension is more than a technical problem. It is a reminder of our place in the cosmos, of how the emptiness around us can shape the story we tell about everything beyond. We have not measured the universe wrongly. We have only measured it from within a hollow, and in doing so, we may have caught the faint sound of the universe laughing softly, aware that it still keeps secrets even from those who dare to measure its heartbeat. For centuries, human history has been a slow and painful process of surrendering our specialness. Long ago, we believed the heavens turned around us, that the sun and the stars danced for Earth alone. Then came Copernicus, quietly rearranging the universe, placing the sun at the center and us at the edges. Galileo lifted a telescope toward the sky and confirmed it, his glass lens shattering not only the illusion of a perfect cosmos, but also the pride of humankind. Centuries later, Edwin Hubble pushed that boundary even farther, proving that our Milky Way was just one among billions of galaxies, each adrift in the expanding sea of space. Every discovery seemed to hum the same melody. We are not special, not central, not chosen. Yet the universe, in its strange humor, may have left one more twist in the story. The KBC Void, this enormous hollow in which our entire galactic supercluster resides, suggests that our cosmic address might be far from ordinary. We are not perched upon a grand structure or nestled in a dense cluster. We are floating near the center of one of the largest empty regions ever observed. By the laws of probability, that should be incredibly rare. The principle that guides modern cosmology, the cosmological principle, states that the universe, on a large enough scale, is the same everywhere. No location, no vantage point, no corner of existence is meant to be privileged over another. Yet here we are, quietly living in an exception to that rule. It is a peculiar feeling, almost contradictory. After all our efforts to erase the notion of being unique, the universe presents us with an emptiness that feels uncomfortably personal. It's as if the cosmos, after centuries of humbling us, leans in close and whispers, "You still haven't escaped the center." Not a center of importance, but a center of absence, of silence, of thinness. This idea unsettles not just science, but philosophy. To accept that we dwell in such a rare environment means admitting that our observations of the universe are, in some sense, biased by location. It bends the comforting thought that the universe is democratic and uniform. For cosmologists, this is a heresy of sorts. Every modern equation assumes that wherever one stands, the universe looks roughly the same in every direction. That assumption has guided our understanding of gravity, expansion, and even time itself. Remove it, and the framework begins to tremble. Still, there is something poetic about this possibility. Throughout history, the universe has humbled us by stripping away our illusions of importance. Perhaps now it humbles us again, not by making us grand, but by placing us in a hollow so vast it reshapes what we believe about reality. To live inside such emptiness is not to be special in the traditional sense. It is to exist in a location that reflects how small, how delicate, how improbable life truly is. We are the echo in a cavern of light, the brief warmth flickering in a region meant for silence. Imagine standing on a mountaintop at night, surrounded by fog so thick that the stars vanish. You might feel at the center of everything, but only because there is nothing around to show your true position. The KBC Void creates a similar illusion. We look outward and see galaxies rushing away, their light stretched and softened, and we interpret that as a sign of cosmic expansion. Yet perhaps part of what we see is shaped by where we are, by the hollowness that cradles us. We are like travelers judging the shape of the world while floating in a balloon, unaware that the air inside the balloon is different from the air outside. There is a subtle irony here. To be at the center of emptiness is to be both nowhere and everywhere at once. The universe does not revolve around us, yet the measurements we make are drawn from this rare void, this cosmic bubble that bends the way light moves and time flows. So while we no longer imagine ourselves as the focal point of creation, the void itself may have placed us in a position that distorts our perception of the whole. Perhaps that is what makes this discovery so haunting. It blurs the line between scientific observation and existential reflection. The question is no longer just about physics, but about meaning. What does it say about us that life arose in one of the universe's emptiest corners? Why here, in this quiet hollow, instead of the bright, crowded lanes of galactic filaments where stars collide and galaxies thrive? Could it be that emptiness offers something stability never could? Space enough for complexity to emerge, for quiet systems like ours to survive the cosmic storms beyond? The thought lingers like a soft echo. For every time we believed we had escaped the idea of being special, the universe has found a way to remind us that our perspective remains deeply personal. The KBC Void might not make Earth the center of anything, but it does make our view unique, a perspective shaped by emptiness, distance, and silence. So perhaps the lesson is not that we are special, but that the universe is endlessly inventive in how it teaches humility. Each time we step away from the center, we find ourselves in a new kind of middle, one drawn not by importance, but by wonder. The cosmos doesn't revolve around us, yet somehow, through the lens of this great hollow, it still finds a way to make us question our place again. In that sense, the void is both a discovery and a mirror. It reflects the long story of humanity's search for meaning in a universe that keeps shifting beneath our feet. It suggests that even now, after centuries of looking outward, the truest mystery may not be in the stars themselves, but in the strange, empty space between them. A space that, against all odds, we call home. When scientists first measured how fast the universe is expanding, they found a rhythm, a steady pulse that seemed to tell them the age of everything. 13.8 billion years. It felt right, elegant, almost sacred, a number that bound together every atom, every galaxy, every moment since the beginning. But numbers like stars can flicker when seen through the wrong kind of light. If the expansion of the universe is actually faster than we thought, as the local measurements suggest, then that rhythm changes. The universe would be younger than 13.8 billion years, closer to 12.7. A billion years may seem like a small correction on cosmic scales, yet it shakes the foundation of everything we think we know about time itself. The problem begins with light. We use light from distant objects as a kind of ruler, a way to measure how space stretches as it travels. But if we happen to live in a region where space expands faster, a void like the KBC, then our ruler is bent. The galaxies we observe appear to be rushing away quicker, not because the whole universe is expanding faster, but because our local bubble exaggerates the motion. Like a swimmer caught in a gentle current, we mistake the speed of the river for our own. When that misperception is written into our equations, the age of the cosmos shrinks. Yet this younger age creates a strange contradiction. Some of the oldest clusters of stars, ancient swarms known as globular clusters, appear to be 13 billion years old, or even slightly older. They are cosmic elders, born not long after the first atoms formed, glowing faintly in the outskirts of galaxies. If the universe itself is only 12.7 billion years old, then these clusters should not exist. It would be as if someone found a tree on Earth older than the planet it grows on. The paradox is impossible to ignore, so scientists are left with two paths to follow. One path says that the problem lies with us, that our position within the KBC Void distorts what we see. This idea is strangely comforting because it preserves the laws of physics as we know them. The universe stays 13.8 billion years old. Timeless equations remain true, and the inconsistency melts away once we correct for our peculiar vantage point. But the other path leads into deeper mystery. Perhaps the laws themselves have changed. Perhaps the force that drives the universe's expansion, dark energy, is not constant, but something more restless, evolving as the cosmos ages. Dark energy makes up roughly 70% of the universe, yet we know almost nothing about it. It acts as a kind of cosmic pressure, pushing space outward, countering the pull of gravity. For decades, physicists assumed it was constant, an invisible background hum that never changes. But if dark energy grows stronger with time, it could accelerate the universe faster today than it did in the past, explaining why the local measurements appear higher. In that case, the universe could still be 13.8 billion years old, but its expansion rate is not fixed. It's rising like the tempo of a song. This possibility is breathtaking because it means the universe is not a simple clock ticking uniformly since the Big Bang. It is alive in some sense, its pulse quickening with age. Space is not a static fabric, but a breathing entity, stretching faster as it empties out. The farther the galaxies drift, the more freedom dark energy has to expand the stage. One day, this acceleration might tear even the largest structures apart, scattering galaxies beyond the horizon of visibility, leaving each one isolated in darkness. Between these two explanations, our local distortion or a changing cosmic force, scientists find themselves torn. Both fit the data in their own way, both preserve some truths while breaking others. It is a choice between humility and revolution. To accept the first is to admit we live in a place that biases our view. To accept the second is to rewrite the very physics that describe reality. Neither path is easy. Both challenge the comfortable symmetry of the cosmos we thought we knew. What makes this debate so mesmerizing is that both possibilities carry poetry in their consequences. In one, the universe remains consistent, eternal in its logic, but we learn that our perspective is fragile, distorted by the emptiness that surrounds us. In the other, the universe itself changes with time, restless and evolving, as if even the cosmos cannot resist the pull of transformation. One interpretation restores order, the other invites wonder. Whichever truth prevails, it forces us to confront how delicately our understanding depends on where we stand. A billion years gained or lost might seem trivial, but for humanity, a species that has existed for barely a blink in cosmic time, it changes the entire narrative. The difference between 13.8 and 12.7 billion years is the difference between a universe with room for patience and one racing toward an uncertain fate. Some nights, astronomers must feel like detectives chasing clues written in starlight, aware that their instruments are also part of the mystery. Every observation is shaped by the very space they seek to understand. The void beneath us, the expansion above, the whispers of light that travel across time, all conspire to remind us that knowledge is never absolute. It bends, stretches, shifts, just like the universe it describes. Perhaps that is what makes the search so human. We measure, we question, we argue, not because we expect final answers, but because each contradiction reveals a deeper harmony waiting to be understood. Whether the cosmos is younger, older, faster, or slower than we think, it remains what it has always been, a mirror reflecting our own hunger to know. And as the debate divides scientists into camps and theories, one thing unites them all: the quiet recognition that the more we learn about the universe, the more it learns to surprise us. Somewhere in the silence between those numbers, the universe keeps its secret intact. Its true age may be 13.8 billion years or 12.7, but the wonder it stirs in us is timeless. Perhaps the only real measure of the cosmos is not in years or light, but in the endless curiosity that makes us reach into the void, searching for the heartbeat of creation. The discovery of the KBC Void left cosmologists standing at a crossroads. One path leads toward rewriting the laws of the universe. The other demands accepting that our cosmic address is more peculiar than we ever wanted to admit. Neither road feels comfortable. One challenges the very equations that have guided modern physics for a century, while the other quietly bends a philosophical cornerstone that has stood since Copernicus, that there are no special places in the cosmos. Yet the void, silent and vast, insists that one of these beliefs must yield. Those who lean toward the first path, the one that rewrites the laws, see the Hubble tension and the void as signs of a deeper flaw in our understanding of gravity or dark energy. Gravity, as Einstein described it, works exquisitely well on the scale of planets, stars, and galaxies. It bends light, warps space, and keeps the universe coherent. But perhaps its reach falters over the greatest distances, or perhaps there exists a subtle correction that we have yet to discover. Some physicists have proposed modified theories of gravity, whispering that the force binding the cosmos might not be constant after all. Others suspect that dark energy, the invisible agent pushing galaxies apart, could be evolving, growing stronger as the universe ages, reshaping its tempo like a slow crescendo. Changing these laws would be monumental. Every cosmological model built on Einstein's equations would have to shift. The balance of dark matter, dark energy, and ordinary matter, the cosmic recipe, might need rewriting. Even the ultimate fate of the universe could change. Instead of expanding forever into silence, it might slow, reverse, or fracture in unexpected ways. To embrace this path is to admit that our current understanding, however elegant, is incomplete, that the universe still hides new forces behind the veil of space-time. The second path is no easier. It requires no new physics, no revised equations, only a quiet surrender of pride. It says that we do not stand in a typical place, that our galaxy occupies a rare and underdense region of the cosmos. The universe remains uniform overall, but our view of it is not. To accept this means admitting that our corner of space distorts what we see, that our perspective is slightly privileged by accident, like a camera placed inside a hollow sphere. In this view, the laws of physics remain untouched. It is our position within the web that tricks us. Yet, this explanation unsettles something deep within us. Since Copernicus, humanity has made peace with the idea that we are ordinary, that the laws of nature apply equally everywhere. The notion that we inhabit an exceptional place, even one defined by emptiness, feels like a betrayal of that humility. It echoes an ancient echo of ego, one we've spent centuries silencing. To live in a void, then, is to carry the burden of paradox. We are both insignificant and strangely central, floating in a bubble that may color our entire view of existence. In quiet conversations, cosmologists confess that both possibilities are haunting. To modify the laws of physics risks unraveling the beauty of Einstein's universe, but to accept a special vantage point risks unraveling the very philosophy of science. Each side carries a kind of discomfort that reaches beyond data and equations, touching something almost spiritual about how humans relate to the cosmos. The debate is no longer just about numbers, it is about identity. Are we explorers of a universal truth, or creatures confined to one distorted view of reality? As the argument unfolds, the universe itself offers no clarification. The data keeps deepening, the tension remains, the measurements grow more precise but not more harmonious. Like two melodies played in different keys, they refuse to blend into a single tune. One camp says the notes must be rewritten, that the instruments themselves are flawed. The other says our ears deceive us, that the echo of the void changes the sound. Both listen to the same song and hear something different. Perhaps what makes this divide so profound is that either outcome reshapes the story of the cosmos. If the laws of physics change across time, then the universe is alive in ways we've never imagined, pulsing with unseen forces that evolve as it ages. But if we are the anomaly, if our location warps our view, then we are reminded that perspective defines reality even on the largest scales. The universe becomes not a single objective stage, but a vast collection of vantage points, each shaped by where it stands within the cosmic web. Some scientists hope for a third option, a subtle compromise hiding between extremes. Maybe the truth lies in a small correction, a quiet blending of local bias and evolving energy, a solution that saves both our physics and our humility. But the cosmos rarely settles for half measures. Its mysteries tend to stretch us until something within must give way, forcing us to see that knowledge is not built on certainty, but on the willingness to live between contradictions. In the end, whether the void reveals a flaw in our equations or in our assumptions, the lesson remains the same. The universe is not what it appears to be. Its simplicity is an illusion, its symmetry a mask. Beneath the smooth patterns we draw across the stars lies a restless complexity, an insistence that truth is never static. The KBC Void stands as a quiet monument to that truth, a hollow that both challenges and humbles us, reminding us that even after centuries of discovery, the universe still keeps the final word. For now, the debate continues. Two great schools of thought orbiting each other like galaxies in slow collision, neither willing to yield, both pulled by the same gravity of wonder. Somewhere between them lies the real answer, waiting, patient, hidden in the silence of the void. In most places across the universe, gravity and dark energy are locked in a quiet struggle. Gravity pulls matter inward, shaping stars and galaxies, while dark energy pushes space itself outward, stretching the fabric of the cosmos. But inside the great cosmic voids, that balance breaks. Gravity loses its strength. There is too little matter to anchor the pull, too little mass to resist the expansion. What remains is an almost pure stage where dark energy performs unopposed, expanding the voids like bubbles swelling in slow motion. These regions, once dismissed as cosmic wastelands, have become the universe's most revealing laboratories. Inside a void, the usual noise of creation fades away. There are no crowded galaxy clusters distorting the data with their collisions or their gravity. The background light is cleaner, the cosmic expansion more visible, the influence of dark energy sharper. To study a void is to observe the universe stripped of its distractions, a pure experiment in how emptiness behaves. Each void grows not through chaos, but through quiet, the space between galaxies stretching as though breathing, the dark energy within pushing evenly in all directions. By measuring that gentle swelling, astronomers can test whether dark energy is truly constant or if it changes with time. The leading theory today, drawn from Einstein's equations, treats dark energy as a property of space itself, a kind of built-in tension, a vacuum energy that remains uniform no matter where or when. But what if that constancy is an illusion? What if dark energy evolves, waxing and waning as the universe ages? To find the answer, scientists turn to the voids. These vast hollows are like cosmic thermometers, their rate of expansion revealing the pressure of dark energy over time. The deeper the void, the clearer the reading. Surveys that map the large-scale structure of the universe, like those from the Sloan Digital Sky Survey and the Dark Energy Survey, have traced thousands of voids, each one a fingerprint of how dark energy has acted through billions of years. When researchers compare the sizes and shapes of these voids across cosmic history, they find hints that expansion inside them might not be perfectly uniform. Some grow faster than predicted, others lag slightly behind. The differences are small, but whisper of a deeper story, one where dark energy could be slowly evolving, its strength shifting as the universe matures. There is something almost poetic about studying nothingness to understand everything. The voids, those vast regions where galaxies are few and silence reigns, may hold the clues to the fate of the entire cosmos. If dark energy is truly constant, the universe will continue to expand forever, each galaxy drifting away until all light fades. But if dark energy grows stronger, the expansion will accelerate wildly, tearing apart galaxies, stars, even atoms themselves. On the other hand, if dark energy weakens, gravity could one day regain control, pulling everything back inward toward a final collapse. Every possibility, the endless drift, the catastrophic rip, or the grand return, depends on how the emptiness behaves. When scientists simulate the universe on supercomputers, they treat voids as the quiet spaces between symphonies, the pauses that define the rhythm of everything else. The patterns of galaxies, the clustering of matter, even the subtle ripples in cosmic background radiation all respond to how those voids expand. Watching them grow is like watching the universe breathe. Each inhalation stretches the filaments of galaxies. Each exhalation deepens the spaces between. Over billions of years, this breathing has written the shape of the cosmic web itself. In a way, the voids are like mirrors, reflecting the true character of dark energy by showing what happens when nothing stands in its way. Inside galaxy clusters, gravity and dark energy wrestle endlessly. Inside voids, dark energy dances alone. It is there that its nature becomes clear, free from interference, free from noise. The emptier the region, the closer we come to seeing the universe's raw intention. For cosmologists, studying voids requires patience and imagination. The data come not from bright explosions or dramatic events, but from the subtle arrangement of galaxies across billions of light years. Each faint dot on a sky map contributes to a larger picture, a map of absence, a cartography of silence. As these maps grow more detailed, the patterns of expansion and contraction begin to reveal themselves like ripples on the surface of an unseen sea. There's also a quiet irony to this work. For most of human history, emptiness was treated as meaningless, a backdrop against which existence unfolded. Yet the more we study the universe, the more emptiness reveals its power. The voids do not merely separate galaxies. They shape them, influence their motion, determine how light bends and time flows. They are not the gaps between the cosmic story. They are part of its language. So when astronomers peer into these enormous hollows, they are not staring into nothingness, but into the machinery that governs everything. Every photon that passes through a void bends slightly. Every wave of gravity slows. Every measurement carries the fingerprint of the emptiness it crossed. In that sense, the voids are not places of absence, but places of truth, where the forces that define reality show their purest form. Perhaps the most humbling lesson of all is that meaning can arise from what seems most meaningless. The places that appear barren, cold, and devoid of structure may be the very ones that hold the universe's deepest secrets. The voids, quiet and forgotten, are not the mistakes of creation, but its confession. Somewhere in their vast silence, the universe reveals its balance, a cosmos built on the dialogue between fullness and emptiness, gravity and release, being and nothing. To study the voids is to listen to that dialogue, to lean close to the whisper of dark energy as it shapes the ultimate destiny of everything. The hollows that once seemed to mean nothing have become the places where the universe speaks most clearly, revealing that in the end, even nothingness has something to say. Drifting in the deepest pockets of the universe, far from the crowded filaments of the cosmic web, there are galaxies so solitary they might never meet another of their kind. They float in the dark like lanterns scattered across a vast ocean, each one burning quietly against the pull of nothingness. These are the void galaxies, rare, delicate, and stubbornly alive in regions where almost everything else has thinned away. Inside the great hollows of space, gravity has little to work with. The dense clusters that breed collisions and mergers are far away, so these galaxies live slow, unhurried lives. They spin gently, forming stars at a measured pace, preserving their shapes for billions of years. Some are small spirals with thin arms curling like ribbons of dust. Others are faint smudges of light, irregular and diffuse, too fragile to form any clear pattern. Their stars are few, their gas untouched, their histories written in quiet isolation. The chemistry of these lonely galaxies is simple. Because they rarely collide with others, they lack the heavy elements forged in those violent encounters. Their stars are made mostly of hydrogen and helium, the universe's original ingredients. To peer inside one is to look back in time, to glimpse how the first galaxies might have appeared before the cosmos grew crowded. They are relics of an earlier rhythm, fossils of creation preserved by solitude. Yet every so often, one of these galaxies flares with sudden energy. A ripple of gravity, perhaps from a faint encounter with a passing cloud, triggers a burst of star formation. New stars ignite all at once, burning hot and blue, flooding the surrounding gas with light before fading again into calm. The galaxy shines brighter for a few million years, a heartbeat on cosmic timescales, then falls silent once more. These moments of brightness are rare but striking, like desert flowers blooming after a long drought, reminding the universe that even isolation can hold sparks of creation. Because void galaxies live in such peaceful conditions, they offer astronomers a natural laboratory to study what galaxies might become without the influence of neighbors. In denser regions, galaxies are constantly reshaped by violence. Collisions that compress gas into stars, tidal forces that twist their arms, black holes that flare and fade as they feed on the debris of encounters. Inside a void, those forces vanish. What remains is purity. These galaxies evolve according to their own gravity, their own chemistry, uncorrupted by the chaos of crowds. Observing them is like listening to a single instrument playing alone, instead of an orchestra. Their solitude gives rise to unique beauty. With so little interference, their disks can remain nearly perfect, thin and symmetrical, while their spiral arms stretch lazily into the dark. Others, especially the smaller ones, appear ghostly, their stars barely visible, like the remnants of smoke after a flame has burned out. Some carry immense clouds of cold hydrogen gas, fuel for generations of stars that have yet to be born. In them lies the promise of futures that will unfold over timescales far longer than the age of life on Earth. There is also something almost philosophical in their existence. These galaxies have spent billions of years adrift in emptiness, untouched by the cosmic drama playing out elsewhere. While galaxy clusters roar with collisions and light, the void galaxies remain suspended in quiet, their motion steady, their light faint but unwavering. They are proof that even in the loneliest corners of creation, complexity endures. Life, in its broadest sense, continues, slow, steady, unconcerned with attention. From a human perspective, they seem to embody stillness itself. In their silence, there is a kind of grace, a rhythm so slow it approaches timelessness. Light from one of these galaxies can travel for hundreds of millions of years before reaching another. Their stars rise and die in complete solitude, their supernovae bloom unseen. No neighboring galaxy will ever reflect their light or feel their gravity. They exist for themselves alone, yet their faint glow contributes to the quiet structure of the universe, a soft punctuation mark in the story of space. For astronomers, studying them is an act of patience. Their distance and faintness make them hard to detect, their features subtle, their histories slow to reveal. But with each observation, we learn more about how galaxies live when left undisturbed. We see how gas gathers, how stars form, how time shapes them without chaos. These lonely lights teach us that creation does not always need drama. Sometimes it happens in stillness, in the invisible folds of nothingness. Perhaps the most haunting image of all is that of one such galaxy, shining alone in the darkness, its spiral arms unfurling like the petals of a flower no one will ever see. Around it, space expands, silent and vast. For billions of years, it has drifted through the emptiness, its stars tracing the same patient orbits, its heart beating softly against the pull of eternity. They are the quiet witnesses of the cosmos, glowing reminders that even in the deepest emptiness, beauty persists. Their light crosses the voids not to be admired, but simply because it must. Because that is what light does. It travels. It endures. These galaxies are like small fires in a frozen desert, fragile yet eternal in their own way. Through them, we glimpse the persistence of existence itself, the stubborn fact that something continues to shine, even when surrounded by infinite night. In the quiet of the cosmic voids, where galaxies drift like islands in an endless sea, the question of life becomes something both fragile and profound. On Earth, life thrives in the tension between forces, the heat of the sun and the chill of night, the chaos of storms and the calm between them. The same balance may hold true on the scale of galaxies. In the dense filaments of the universe, where galaxies collide and tear each other apart, the cosmos burns hot and fast, birthing stars that live briefly and die violently. But in the voids, where the pace slows and the noise fades, there may exist a kind of cosmic serenity, a gentler environment where time itself feels thicker, where stability lasts long enough for something delicate to take root. It is an idea both beautiful and unsettling, that the emptiest places might also be the most patient. Within these hollows, galaxies evolve quietly, rarely disturbed by collisions that would shatter their fragile balance. Their stars live longer, their paths unbroken, their environments calm. The radiation from neighboring galaxies is faint, the cosmic background cooler, the gravitational tides softer. In such stillness, planets could circle their stars for billions of years without interruption, without the sudden violence that often resets the clock of life elsewhere. From that perspective, a void might not be a desert at all, but a cradle, offering the one thing life needs most, time. Yet the stillness comes at a price. The galaxies that form in these regions are small and poor in metals, the heavy elements forged in generations of stellar death. On Earth, every atom of iron in our blood and every trace of calcium in our bones came from ancient stars that lived, exploded, and scattered their remains across space. Without enough of those earlier generations, there may be too little raw material for planets like ours, too little rock, too little complexity, too few chances for chemistry to blossom into biology. A galaxy inside a void might host countless stars, but few worlds capable of harboring oceans or air. The emptiness that grants peace also withholds the ingredients of life. This duality gives the idea of life in the void a haunting symmetry. The conditions that make survival possible also make existence unlikely. Too much chaos, and life is destroyed before it can begin. Too little, and it never forms at all. Somewhere between those extremes lies the narrow band where life can endure, the cosmic equivalent of a temperate climate. Our galaxy, perched near the middle of a great hollow, might rest within that delicate balance. Not too crowded, not too quiet. A place where the universe moves slowly enough for complexity to grow, yet active enough to supply the materials needed to build it. Sometimes astronomers wonder whether that balance is rare. In the deep silence of the cosmic voids, there could be other galaxies with planets orbiting their lonely stars, circling through centuries of light untouched by any outside voice. On one of those worlds, life might have arisen in the same patient way it did here, under skies filled with fewer stars, but more time. Somewhere in that infinite stillness, perhaps another mind has lifted its gaze toward the darkness and asked the same question we ask tonight. Are we alone in this emptiness, or is someone else out there, adrift in their own pocket of silence, wondering the same? The thought stretches the imagination to its breaking point. Across the billions of light years that separate these voids, communication would be impossible. Light itself takes eons to cross the darkness. Yet the idea that life could exist in multiple hollows, each sealed off from the others, each unaware of its neighbors, carries a strange poetry. It suggests that consciousness might bloom again and again across the universe, not in clusters or crowds, but in isolation, like lanterns glowing quietly in the vast dark sea. Perhaps the greatest paradox of all is that the same forces that create separation also create the conditions for reflection. Without the emptiness, there would be no stillness, no space for life to become aware of itself. The void, which seems at first to be the enemy of life, might actually be its silent companion. It slows down the cosmic clock, allowing fragile patterns to emerge, to think, to wonder. Even the loneliness of such a place has its meaning, for to recognize isolation is already to possess the kind of awareness that defines life itself. When we look up at the stars, we see their light crossing the dark gulf, ancient and tireless. Perhaps, somewhere in another hollow, other eyes are watching their own faint constellations, tracing their own myths across the void, unaware that their questions echo ours. The emptiness between us is vast, but the curiosity that arises within it may be the same everywhere. That, in a way, is a form of connection, a bridge made not of matter or energy, but of wonder. Life, wherever it appears, is the universe observing itself. Whether born in crowded clusters or lonely voids, it transforms silence into awareness. To exist at all is to participate in that transformation, to bring meaning into places that seem to have none. The voids are not empty in the truest sense. They are full of potential, full of the quiet possibility that somewhere, somehow, the cosmos has once again learned to ask its favorite question. Who else is out there, looking back through the darkness, searching for a sign that it is not alone? Maybe the universe is not what it seems. For centuries, we have watched the stars and trusted what they told us, believing that light carries truth faithfully across the dark. But light can bend, space can twist, and the void around us can shape every observation we make. So now we find ourselves standing on the edge of an unsettling question. Is the universe deceiving us? Or are we merely gazing through a cosmic mirror, warped by our own position inside it? The more we study, the clearer it becomes that the universe is not a grand cathedral of matter, but an architecture built mostly from absence. More than 90% of all that exists is emptiness. The galaxies, brilliant as they are, float on thin threads of light stretched across a canvas of nothing. In between, vast hollows open like silent oceans, their darkness deeper than any night we know. It is within one of these hollows that our own galaxy drifts. A tiny swirl of stars suspended inside a bubble so large that it defies intuition. We like to think of the universe as something we can map, something that can be measured, drawn, and understood. Yet the KBC Void reminds us that we are not standing outside looking in. We are inside the very thing we are trying to comprehend. Every image, every equation, every number we write down is shaped by that vantage point. It is as though we are trying to describe the shape of a mirror by staring at our reflection in it, never quite sure where the surface ends and the distortion begins. Perhaps that is why the universe feels both intimate and unreachable. We can describe the birth of stars, the structure of galaxies, the fading echo of the Big Bang itself. But the more precise our measurements become, the more we sense that something is subtly out of place. The emptiness that surrounds us does not simply sit there. It participates, bending our understanding, reshaping the rhythm of time and the meaning of distance. It might be that the cosmos is not lying to us at all. It is simply more complex than our minds can hold. Its truths hidden behind layers of perception shaped by gravity, light, and motion. To the universe, we are not observers standing apart. We are part of its geometry, part of the distortion, part of the mystery. The illusion is not that the universe deceives us, but that we ever thought we could see it clearly. Still, there is something deeply human in our effort to try. Across thousands of years, we have built instruments to extend our senses, theories to stretch our reason, languages to hold what cannot be held. We reach into the void with questions, and sometimes the void answers, not with certainty, but with wonder. It shows us how fragile knowledge can be, how every discovery opens another layer of mystery. The more we learn, the more we realize that understanding is not a destination, but a long conversation between light and silence. To live in such a universe is both humbling and extraordinary. We exist in one of its emptiest corners, yet within that emptiness, consciousness has bloomed. The same cosmic stillness that isolates us also allows us to survive, to think, to look outward. The void has given us distance, but it has also given us perspective. It has made us aware not only of our smallness, but of the astonishing fact that small things can ask such large questions. Perhaps the real beauty of the KBC Void is not what it reveals about the universe, but what it reveals about us. That we are capable of noticing the hollowness around us, of wondering whether our view is true or distorted, shows that curiosity persists even in the quietest places. The void reflects us back to ourselves, not as insignificant, but as part of the very story it tells. A species of stardust trying to see its own reflection in the fabric of reality. Maybe the universe is not playing tricks. Maybe it is inviting us to look closer, to see that truth is not a single point, but a field of perspectives, shifting with each new discovery. From within our great hollow, we see the cosmos through a softened lens, blurred by distance and shaped by time. Yet even through that distortion, the light still reaches us, carrying across billions of years the faint message that existence endures. In the end, we may never know whether the universe is deceiving us or simply revealing itself in ways we cannot yet comprehend. But perhaps that uncertainty is the point. The void is not an answer, but an invitation to wonder, to question, to marvel at the strange fact of being conscious in a universe that seems both infinite and intimate. When we gaze into the night, into the quiet between stars, we are not just seeing emptiness. We are looking at the shape of everything we cannot yet understand. The darkness does not mock us, it reminds us. It reminds us that we are still learning to see. In this universe of endless hollows, maybe the most haunting truth is not the emptiness itself, but what it reflects. It mirrors back our longing, our curiosity, our small but persistent flame of awareness. And somewhere within that reflection lies the quiet realization that the void is not our enemy. It is our teacher, whispering softly across the ages that to be tiny, to be uncertain, to be lost in wonder, is the very thing that makes us alive.